Humans are curious creatures. We look up at the night sky, see distant worlds, and wonder what it would be like to visit them. Saturn, with its magnificent rings, often captures our imagination. Imagine yourself poised at the edge of Saturn's upper atmosphere, ready for an unprecedented leap. This is a journey into the unknown, a dive into a world vastly different from our own Earth. The sheer scale of Saturn is mind-boggling. It's a gas giant, a colossal sphere of hydrogen and helium. This journey would be a descent into ever-increasing pressure and temperature, a one-way trip into the heart of a magnificent yet inhospitable giant. While we cannot physically make this jump, science allows us to simulate it. We can use our knowledge of physics and planetary science to piece together a picture of this incredible, hypothetical journey. Prepare yourself for a cosmic dive into one of the most fascinating objects in our solar system. Saturn is not like Earth. It doesn't have a solid surface you can stand on. It's primarily a giant ball of gas. Think of it as an enormous, swirling ocean of gases. The main components are hydrogen and helium, the lightest elements in the universe, making up most of Saturn's bulk. These trace elements contribute to the colors and features we observe in Saturn's atmosphere, forming the beautiful bands and storms. The atmosphere of Saturn is incredibly deep, extending thousands of kilometers downwards. As you descend, the gas becomes denser and denser, with no distinct point where the atmosphere ends and the planet begins. The outermost layers of Saturn's atmosphere are very cold, as Saturn is very far from the Sun and receives much less solar energy than Earth. However, as you go deeper into the planet, the temperature starts to rise. The planet generates its own internal heat, a remnant from its formation billions of years ago. The visible part of Saturn, what we see through telescopes, is actually its cloud tops. These cloud layers are stacked, much like different types of clouds on Earth, but the scale and composition are vastly different. Let us begin our hypothetical jump. As you enter Saturn's upper atmosphere, the first thing you would notice is the extreme cold. Temperatures here can plummet to around minus 173 degrees Celsius. The air, or rather gas, would be incredibly thin at these altitudes, offering little resistance initially. You'd begin to accelerate due to Saturn's gravity. As you fall deeper, the atmospheric density would gradually increase, and you'd start to encounter the uppermost cloud layers, primarily composed of ammonia ice crystals. Imagine falling through a wispy, freezing fog. The colors around you might be pale yellows and golds, hues that come from chemical reactions in the atmosphere. The speed of your descent would increase significantly. Saturn's gravity is strong, about 91% of Earth's gravity at the cloud tops. As the atmosphere thickens, friction would start to play a role, generating heat on your spacesuit and slowing your fall. The journey through these initial layers would be a rapid one, passing through different atmospheric pressures and compositions quickly. As you continue your descent into Saturn, you'd pass through the ammonia ice clouds. Below this layer, scientists predict a region of ammonium hydrosulfide clouds. The temperature here would be slightly warmer than the layers above. However, warmer is relative. It would still be incredibly cold by human standards, perhaps around minus 73 degrees Celsius. The atmospheric pressure would be increasing dramatically. On Earth, we experience about 1 bar of pressure at sea level. By this depth in Saturn, the pressure could be several times that. This increasing pressure would be a significant factor. Your specialized spacesuit would need to withstand these crushing forces. If it were to fail, the consequences would be instantaneous and catastrophic. The gases around you would become much denser, making moving through them feel like swimming through an increasingly thick fluid. Your rate of descent might slow somewhat due to this increased density. However, gravity would continue to pull you relentlessly downwards. The visual experience would also change. The light from the sun would become dimmer as you penetrate deeper into the clouds. The colors might shift as the chemical composition of the atmosphere changes. Reaching the hypothesized water cloud layer on Saturn would be a significant milestone in your descent. Here, temperatures hover around the freezing point of water, 0 degrees Celsius. This might sound relatively mild compared to the frigid upper layers. However, this warmth is accompanied by a crushing increase in atmospheric pressure. We are talking about pressures potentially tens of times greater than Earth's sea level pressure. Your spacesuit would be under incredible strain. The very air, or rather gas mixture, would be so dense it would feel like moving through a thick liquid. The presence of water, even as ice or vapor, is intriguing. On Earth, water clouds are common. On Saturn, they exist deep within the atmosphere, hidden from direct view. Falling through this layer, you might see vast expanses of icy particles. Perhaps there would be strange forms of precipitation, different from earthly rain or snow due to the exotic pressures and temperatures. The sunlight filtering down this far would be very faint. The environment would be dim, illuminated mainly by any lightning from Saturn's powerful storms. The physical experience of falling would be intense. The dense atmosphere would create enormous drag. As you fall beyond the water cloud layers, you enter a region of Saturn's atmosphere unlike anything we can easily imagine. The temperature continues to rise dramatically. This is not due to sunlight, which barely penetrates this deep. Instead, it is due to the immense pressure and the internal heat radiating from Saturn's core. Temperatures could reach thousands of degrees Celsius. This is hot enough to melt lead, then iron, then most known materials. The pressure at these depths is almost incomprehensible. It would be millions of times Earth's atmospheric pressure. The hydrogen and helium gases are compressed to such an extent that they start to behave in strange ways. They are no longer gases in the traditional sense. They become a supercritical fluid. This is a state of matter where the distinction between liquid and gas blurs. Falling through this supercritical fluid would be like swimming through an incredibly dense, hot, and soupy medium. Visibility would be zero. The immense pressure and density would prevent light from traveling any significant distance. You would be in complete darkness, surrounded by this exotic, super-pressurized fluid. The forces acting on your body, or what remains of your protective suit, would be unimaginable. Let's be scientifically frank about what would happen to a human body during this Saturnian plunge. Without an incredibly advanced hypothetical spacesuit, the journey would be over almost instantly. In the upper atmosphere, the extreme cold, around -173 degrees Celsius, would cause fatal hypothermia within seconds. The lack of breathable air would lead to asphyxiation. Even if you had an oxygen supply, the low atmospheric pressure initially would cause your bodily fluids to boil, a grim phenomenon known as ebullition. Assuming you have a spacesuit that somehow protects you from the cold and provides air, the next major challenge is pressure. As you descend, the atmospheric pressure increases exponentially. Even the most robust materials we know would eventually buckle and implode. If your suit were breached at a depth where the pressure is, say, 10 times Earth's atmospheric pressure, your lungs would collapse. Your body would be crushed by the immense weight of the gas column above you. This would happen long before you reach the truly extreme pressures deeper within the planet. Initially, you would accelerate due to gravity. As the atmosphere thickens, drag would increase, potentially causing violent buffeting and extreme G-forces. These forces could easily render a person unconscious or cause severe internal injuries. The human body is simply not built for such extremes. A common misconception about gas giants like Saturn is that if you fall long enough, you will eventually hit a solid surface. This is not the case, at least not in the way we think of a surface on Earth. Saturn is primarily composed of hydrogen and helium. These gases become denser and denser as you go deeper. Eventually, they transition into exotic states like supercritical fluids and then metallic hydrogen. There is no distinct solid ground to land on. It is a gradual transition from gas to something much denser, but not a solid surface in the terrestrial sense. Imagine trying to land an airplane on a cloud. That gives you some idea, though Saturn's clouds become unimaginably dense. The pressure and temperature increase to such extreme levels that solid materials cannot exist in their familiar forms. Any rocky or icy material that Saturn accreted during its formation would have sunk towards the center. Scientists theorize that Saturn might have a relatively small, dense core at its very center. This core could be composed of rock, ice, and heavier elements, under conditions of millions of bars of pressure and tens of thousands of degrees Celsius. However, reaching this core is practically impossible. Long before you got anywhere near it, the extreme conditions of the metallic hydrogen layer would have obliterated anything we could send. The dream of walking on Saturn will remain just that, a dream. Beyond the terrifying prospect of falling into it, Saturn is a planet full of wonders. One of its most famous features, its rings, are not solid. They are made up of billions of individual particles of ice, rock, and dust. These particles range in size from tiny grains to a few as large as mountains. The rings are incredibly thin, perhaps only tens of meters thick in most places, despite stretching out over 280,000 kilometers. Saturn is also the least dense planet in our solar system. Its average density is less than that of water. This means if you could find a bathtub big enough, Saturn would float. Despite its enormous size, about 95 times the mass of Earth, it is remarkably fluffy on a planetary scale. The planet has a very fast rotation. A day on Saturn is only about 10.7 Earth hours long. Finally, Saturn has a large family of moons, over 80 confirmed so far.